All right. When you write a balanced chemical equation, when you balance your equation, it basically means that you have the same number of atoms on the left as you have on the right. So when I write an equation and I balance it, it means that I have 2 atoms of sodium on this side. I've counted 2, so I have to have 2 atoms of sodium on this side. But now in the lab, we cannot work with a single atom or even 2 atoms. They're too small. I don't have a tweezer that's little enough or a microscope that's strong enough that I'll be able to see any atoms at all. So what we work with in the lab is moles. So we work with moles. A mole is equal to 6.02 times 10 to the 23rd atoms. So if I have 2 atoms here, that's the same thing as 2 times 6.02 times 10 to the 23rd atom. Now, is there an easier way to say 6.02 times 10 to the 23rd without having to say 6.02 times 10 to the 23rd? Mole. So what we would say, instead of saying 2 times 6.02 times 10 to the 23rd, we would say this represents 2 moles. And your book would say 2 moles of atoms. Okay? So this 2 represents moles, and we can say, well, it represents atoms as well. So we say that 2 atoms, we counted them. So this 2 is exact. It has a gazillion significant figures. It's exact. So here we would have how many moles? 1 mole. We have 2 atoms in each molecule, okay? But we have 1 mole of atoms, of molecules, not atoms, molecules. All right, so how many moles do we have here? 2. All right, so notice that there's a correlation between the coefficient and the number of moles. Okay? So now we're going to learn how we can use a balanced chemical equation to calculate another compound or element in that balanced equation. All right, so we're going to start with, I'm going to write a problem up here. If I have, and you need to write this down because this is a practice problem for you. If I have 5.3 grams of sodium that reacts with chlorine, how many grams of sodium chloride?
Okay.
Yes.
Do you have to fit it all?
Okay. Sodium chloride be produced. Okay. Go again. So when you read the problem, that's the first step on page 2, is to read the problem and underline keywords as you go. Also underline the chemicals as you read. Some of the keywords you're looking for are reacts, or reaction, or burns, or combust, combustion, decompose. These are things that would indicate there's some kind of reaction going on between these things. It might say sodium burns with chlorine, or sodium synthesizes with. Synthesize would also be an indication. Then on the other hand, these things are all reactants. So they're going to be written on the left of the yields mark. The other words you're looking for are produced, formed, released, released, things that would indicate that you have something produced. And produced would be products. If it's released, it's produced. Otherwise, it wouldn't be available at the end of the reaction to be released. All right, so here, I'm going to read the problem again. And the problem says, if I have so many grams, I really don't care about how many grams I have right now. I'm going to care about that when I start the work. Right now, I'm trying to find out what balanced equation I need to write. So I have sodium reacts with fluorine. And I have sodium chloride produced. So those are the word clues that I'm going to use to write my balanced equation. I have Na plus Cl, and I'm going to produce sodium chloride, NaCl. So now I have to go through my usual process. I have to look for magic 7. I have to make sure my spaces are balanced. So my Na is a +1 and my Cl is a -1, so that last space is balanced. And I have to look at my periodic table to see if this is a magic 7, and I have to look at it to see if this is a magic 7, and so that one is a magic 7. Now I have to balance side to side, and it's balanced. Now the next step, you're going to think it's a waste of your time, and you're not going to want to do it. I'm telling you, it's not a waste of your time. There are harder problems down the road that it comes into play. So the next step is to write what you know and what you're looking for above the appropriate chemical in the balanced equation. That's a step I left out between 2 and 3. Write your given and what you're looking for above the equation. Well, I'm given sodium, 5.3 grams. I'm looking for sodium chloride, X grams. So I write them above. Now I'm on step 3. Step 3 says write what you're looking for. What am I looking for? X grams sodium chloride is equal to what I know. Well, I know 5.3 grams of Na. Now I'm going to try to just move parts of this. Good, that worked out well. Okay, so that worked out all right. Now I'm going to do a fancy kind of factor label. The fancy kind of factor label. Remember, factor label is when we draw a long plus and we do some math. This fancy kind of factor label is called stoichiometry. It is a 3-step process most of the time. In the 3 steps, the A step and the C step don't always have to be done. And I'll talk to you about when they don't have to be done as we go. All right, so I'm going to erase these key words. I hope you already have them written down. Don't, I'm sorry. All right. So the first step, yes. I accidentally brought it down. When I moved everything, it came down from the CL. Came down from the CL. When I moved stuff down, it was supposed to be there. All right, so the first step is to change it to moles. The first step is to change whatever unit you have to moles. So A step, change to moles. Okay. Now, if it's already moles, do I need to change it to moles? No. If you got a coat on and you're going outside and Mama hollers, put your coat on, you're going to put on another coat? You already got your coat on, you're going to do it twice? No. So if I already had moles, if this unit were moles, I could skip the first step because I don't have to change it to moles. It's already there. But I don't have moles. And we have to remember from earlier in the year that 1 mole is equal to 6.02 times 10 to the 23rd units, atoms, whatever it is equal to the GAM or the GMM. Now, we are not ever, for the rest of the year, going to use that. Aren't you glad? So what you have to remember is that 1 mole is equal to the GAM is equal to the GMM. Where do I find the GAM, the GMM? Periodic table. I add stuff up. In the case of GMM, on GAM, I just look it up on the periodic table and round off to the nearest 100. 100. All right, so I'm going to use this equality that 1 mole equals the GAM. What unit do I need on the bottom to get rid of? Got to get rid of something. Grams of Na on the bottom. Where am I going to get the number of grams of Na? Periodic table, and it's 22.99 grams of Na. And I need to change it to moles. So I need moles up here. And I'm always going to write a 1. When I just look at the periodic table, it's always equal to how many moles? 1. So I'm always going to put a 1 right there. And you notice on your handout it says always put a 1 here. So always. Down here, I use rounded off to the nearest 100. All right. Now the second step. This is the A step, and if I'm already given moles, I don't have to change it to moles. On the B step, I'm going to use what's called the mole to mole ratio. Now let me go back. Not ration. Ratio. Let me go back up here for just a second. Look at what it says under step A on your page 2. What does it say underneath the GMM? Subscripts only. So I only take, what's the number of atoms of Na there are? What's the subscript? 1. So I have mentally multiplied 22.9 times 1. I did not look at the 2. I do not look at the coefficient until I do the B step. The B step is the only place you use coefficients. Write it down. B step, right there out to the side. The only place you look at the coefficients. Because some of you don't want to look at coefficients on the A and the C step. Only on the B step are you going to use coefficients. All right. Now I'm going to cancel grams of Na, and I've got moles of Na, and this is the step that allows me, the B step, allows me to move from one part of the balanced equation to another part. So what part am I moving away from? Where am I right now? Na. So I'm going to put moles, because I got to cancel moles, Na. How many moles of Na? Look at the balanced equation. 2. So this step, I have to look at the balanced equation, and I have to look at the coefficients. So I have to look at the balanced equation, and I have to look at the coefficient. So the coefficient for Na is a 2. So I'm going to put a 2 right there. This allows me to cancel moles of Na. Where am I trying to get to? Where am I trying to end up? What does it say over there? X grams of NaCl. So I need moles of NaCl. Now I abbreviate the mole-to-mole ratio for the rest of the year. When you see M/M written up there, that means mole-to-mole ratio. Eventually, I'm going to quit writing in the numbers. I'm just going to put the M/M, and you're supposed to know what goes in that spot. All right, so I'm looking at moles of NaCl. Look at the balanced equation. How many moles of NaCl? 2. Remember I said this represented a number of moles of molecules. Moles. Okay? Now, to get this, I use the subscript in the space. To get this, I use the coefficients in the spaces. And the last step, the C step, is to change it to the unit I need. All right, in this case, I need what unit? Grams. Grams is the unit. Na is not a unit. NaCl. Grams is the unit. So I need grams. So that means I've got to end up with grams up here. So what do I have to get rid of? Moles. So, moles of NaCl. Reckon what number is going to go by that moles? 1. It's always a 1 whenever you do this C step. Now, before we go on any further, let's pretend for a second that the question said how many moles of NaCl. If I stop right now, what unit do I have? Moles of NaCl. So I could not have to do this last step, depending on what the question asks. If it's already moles, don't change it to something else. Just leave it where it is. Whenever I cancel out, this is the unit I'm left with right here. So I'm going to need to put the GMM up here of NaCl. And that's grams. So I come down here and I say Na, 22.99 plus Cl is 35.45. Add that up, and I get 58.44 grams. Okay? Now, significant figures. Calculation, I got 5.3 divided by 22.99 times 2 divided by 2. Do we really have to do that? If you know you don't have to do that, then fine. But if you aren't sure, divide it, multiply times 58.44. So 5.3 divided by 22.99 times 2 divided by 2 times 58.44. The answer is what? How many different figures do I need? 2. So what's the answer? 13. 13 what? Grams NaCl. And that is the box answer. Okay? 2 significant figures. Now, what do I look at for significant figures? I always look at this, this, and this. Those are the 3 places I have to look for my significant figure. I do not look at my mole-to-mole ratio because we counted atoms and then interpreted that into moles. So they're exact to as many numbers as we know for Avogadro's number. So we don't look at those to limit our significant figures. We look at where we rounded off here, and where we rounded off here, and what was given in the problem. Okay? So 3 significant figures. All right, so I'm going to look at this. This is the sample problem on your handout. It's on page 3, and it's the significant figures on it are kind of sucky. I got them from the internet, and they didn't write down the correct number of significant figures. So I said it's 2 pages, front and back. All right. So first thing we're supposed to do is to read the problem and underline those things that are chemicals and those things that will help me decide which ones are reactants and which ones are products. So as I read, I have iron pyrite, but it tells me right there that's the symbol part, so I'm just going to underline the symbol, FeS2. Is not removed from coal. Oxygen from the air will combine with, and it says this right here, but I may not end up using that for some reason. We'll see as I go through. If the furnace burns an amount of coal containing 100 grams, don't really care about that 100 just yet. I'll worry about that when I get there. We're going to pretend that it's got a dot by it for our significant figure purposes. All right, how much SO2, an air pollutant, do I care it's an air pollutant? Probably not to work the problem. Might be some interest if I'm worried about the environment, but SO2, and then it goes on to tell us that iron 3 oxide is the other product, is also produced. So, I'm going to have FeS2, what am I going to combine with it? What's the other reactant? Oxygen. Plus O2. Now, I can't tell you every possible word they can use to indicate their chemical reaction. I'm trying to give you a general idea so you can use your own intelligence to read the problem. Okay? All right, plus O2. Now, with both the iron and sulfur as the coal burns. I didn't type it up very well. So it says the oxygen will combine with both of those. So that means when it says that, I'm probably going to have that oxygen make a new compound that's a couple oxides with those two chemicals. All right, so I come on out here and I say, okay, well, I know SO2 is produced. And I know iron 3 is produced. Now, if I stop right there and we just look at this equation as it is, it looks like a single replacement reaction, doesn't it? And if it were a single replacement reaction, your other product would be iron. So I had to tell you what the other product was in the parentheses so you could finish the equation because you can't predict that product, not based on what we've learned. And remember, I will never ask you to predict more than 2 products. Some of you predicted more than 2 products on your test, but I will never ask you to predict more than 2 products. So you're never going to have more than 1 plus right there unless I tell you everything that is produced. Okay? So the other thing is produced is Fe2O3 because it's iron 3. All right? Now I'm going to balance. I'm going to count the number of F's, and I already know that I get the odd-even thing going on with those O's with the F's the way they are. So I'm going to put a 4 right here, and I'm going to put a 2 right here, and an 8 right there, and an 11 right there, so it's balanced. Okay? Now you can do that same balancing that I just did on your own, because I know you can all do that. Hopefully. All right. So now I've got my balanced equation. I've read the thing, I've underlined, I've used that to help me predict where everything goes. And now I'm interested in what I'm looking for and what I know. Well, I know that there are 100 grams of this. So I write it up here. And I'm looking for X grams of that. That helps me because if I get lost in what I'm doing, rather than have to wade through that big old long problem again, I've got it kind of condensed into what the important stuff is. All right, so I said equal to X grams of SO2 is equal to 100 grams of FeS2. The A step is to change what you know to moles. Well, since it's not moles, I've got to do the A step. So the A step, and I'll get another color. The A step, I'm always going to put 1 mole up here of Fe, in this case, S2. Now I have to put the GMM down here. Where do I get the GMM? Periodic table. Now, for the time being, we're not going to go to the trouble of looking it up and round it off to nearest hundredths because your sample problems didn't do that. I'm just going to put 120 with a decimal after it so my significant figures will come out. Grams of FES2. Okay? Now my B step is the mole-to-mole ratio. Remember, this is always a 1. Up there on top. My mole-to-mole ratio, where do I get my mole-to-mole ratio? I look at the coefficients. Did I look at the coefficients to get this number? I looked at the subscripts. I took 1 iron and 2 S's and added them together. Subscripts only right here. So here I'm going to say moles, grams of FES is already gone, moles of FES2. How many of them are there? According to my balanced equation. 4. 4. Now I'm going to leave moles of FES. Where am I trying to get to in this balanced equation? Do I want to know Fe2O3? Do I want to know O2? I want to know this. That's where my X is. So I'm going to say 8 moles of SO2. Now, my C step is to take the GMM and put it up here, and I'm going to put 1 mole of SO2 down here. Now for our significant figure thing, this is going to be 64.0, we'll say, grams of SO2. Otherwise, we'll end up with the wrong number of significant figures according to the answer. Whoever did this online didn't fix that. I fixed it for next year. All right. So I take out my calculator. I say 100 divided by 120 times 8 divided by 4 times 64. This 1 is always a 1. I get people who get carried away and want to put other numbers there. This is always 1, and this one is always 1. Don't get carried away with those coefficients. Okay? So when I get through, I find out my answer should have 3 significant figures, and my answer is 107 grams of SO2. Box answer. Now, I've worked it on the board. It's on page 3 of your handout, worked out for you step by step. This has got it all in one thing. You know, when you get through, it's just all one big thing. It's not all those little bitty steps. But it is a pattern. You keep doing the same pattern over and over and over.